Hey guys, so right now we're going to go over, instead of wondering if it is going to be continuous, we're going to make two equations continuous. So in this case, if we look here, k does not have a set variable. We get to decide what k is. In fact, we need to decide what k is so that when x is 3, they touch. We want to make this a continuous function. So here we go. What we need to do is we need them to be the same when x is 3. When x is 3 is the key word here. So when x equals 3, this is k times 3 squared, right? When x equals 3 here, this is k times 3 plus 12. Now we want them to be the same. How would I say two things are the same mathematically? It's not with a subtraction sign. It's not with an addition sign. It's with an equal sign. Good job. We want them to be equal when x equals 3. So you set the two equations equal, and for whatever the x value is, you replace the x's with that value. So here, we get 9x equals 3x plus 12. Now it goes back to the algebra. You got to remember how to do some algebra here. We need to get that should be x, that should be k. All right, so I get a little nervous sometimes while I'm on video. It's okay. I make mistakes. Let's see, we're going to subtract 3k from both sides because we want our k's to be together. That gives me 6k equals 12. Now guys, you could have also taken the 9k, moved it over here. Then you have everything over on this side, then you'd subtract the 12 from divide. It doesn't matter, it all works out the same. Divide by 6, it gives me k equals 2. So, over here, when k equals 2, this becomes a continuous function. If it is anything other than 2, it is not continuous. Okay? It is not continuous if it is anything other than 2. All right, let's try another problem. Here we go. We are doing 5 problems total. The last 2 problems today are really tricky. We're going to do this one together. The next one I'm going to let you try on your own. The last 2, make sure to definitely watch the last 2. If you feel like, oh, this is easy, I've got it, at least watch the last 2 before you blow me off and jump onto the assignment, okay? So here, we want to make them the same. So we're going to do k times 4 plus 3 equals k times 4 minus 2. We've got k4, k4. I'm going to subtract k4 from this side, subtract k4 over here. That leaves me with 3 equals negative 2. All my k's are gone. Huh? That's weird. Guys, does 3 ever equal negative 2? Is that ever true? No, it's not true. Okay, it's not true. So let's think about what this problem was saying. We have kx and kx. What is the slope or the gradient of both these lines? Both these lines have a slope of k. They have the same exact slope. When two lines have the same slope, do they ever cross? No. Will they ever intersect? No, not unless they're the exact same line. And they're not the exact same line here. So in this case, there is no k value that would make this work. Here, there is no k value. So you just leave it as an empty set. You could say no answer. Okay. For delta math, that's probably how you would put the answer in. Just, there's no answer, all right? There is no way for these two lines to ever possibly be continuous. It can't work. They're going to be parallel. They're going to be starting at different spots. They have the same exact slope. Doesn't work. All right, this one's your turn. Give this one a try. Can you make it continuous? Pause the video if you need to. Here's the answer. Again, pause the video if you need to. We've got k 4 squared plus 3 equals negative k 4 squared. All right? Well, we want to get this k4 squared, which is 16k, over to this side, so I have minus 16k minus 16k. Ooh, that gives me negative 32k. Woo! Because that's 4 squared as well. So negative 16 minus 16 is negative 32. Over here we drop down to 3. Divide both sides by negative 32. And yeah, you get a weird answer. You get k equals negative 3 over 32. Okay? That is the correct answer. When this k is negative 3 over 32, this is a continuous function. So technically, this becomes positive, doesn't it? Because 2 negatives make a positive. All right, 2 more problems left. The next 2 are a little tricky. All right, these are the last 2. These are the ones that I told you to stick around for, because these are the ones that can get a little bit more tricky. And it's when you have a larger equation, all right? So when we have a larger equation, we have to figure out if the graph is one of 3 types of graphs. So we're saying at negative 2. So at negative 2, this dotted line, there are 3 different things that could happen. The first thing that could happen is it's just a normal line. We plug in negative 2, we get a nice answer, you're done. The other thing that could happen is you get an asymptote at negative 2, in which case there's no point that you could use to fill in and make this a continuous graph. The third thing that could happen is that there's a hole there. Well, if there's a hole there, then we just plug the point in right there and it would become continuous, all right? So we need to determine, is this a continuous line? Is this going to be an asymptote? Or is this going to have a hole? Okay, it's going to be one of those 3. If it's an asymptote, there's nothing we can do for it. Kind of SOL. So the easiest thing to do, and what I would advise, is graph it on your calculator. So here we go. We've got our handy dandy calculator. I'm going to go to my graphing systems. So I'm going to come up and I'm going to do x squared plus 3x. Well, plus 3x plus 2 divided by x squared plus 5x plus 6. I did that by going to the y equals button. If you're on a TI Inspire calculator, you do it a little bit different. Okay. Now I go to trace. I should probably set my window first. There you go. It's going to trace it for me. So it looks like we've got an asymptote. So if I follow my trace button over, hold on, let me draw off my plots. That should make it a little bit easier. Okay, I follow it over, and I can see that as I'm getting close to x equals negative 3, as x is getting close to negative 3, it makes an asymptote. But we care about x equals negative 2. So if I come to negative 2, type in negative 2, it gives me nothing. Nothing? Well, it's not an asymptote, okay? Because there's not an asymptote at negative 2. In fact, I can even zoom in a little bit more. Okay, so again, I just zoomed in a little bit. Negative 2, you can see, is right there. You can see negative 2 on the graph. It looks like there is a line there at negative 2. Okay, negative 2 is pretty close to right there. We're just not sure exactly where it is. There's negative 2.02, negative 1.91. So it's really, really close. We're just not exactly sure how close because there's a hole. All right? So what we can do is we're going to estimate. How close can I get? Well, how about negative 2.000001? And I get a number pretty dang close to 1. Let's go to the other side. Let's say negative 1.999999999. Ooh, it's just about -1. Okay, so as this line is getting close to -2, so as x is approaching -2, we get the y value is -1. So if k is -1, it would fill in that hole, the missing point. Okay, that's what's happening. I'll draw it out a little bit better. Right here at -2, there's a hole on the line. Okay, so right there, there's a hole. So if we can fill in the hole with k equals -1, bloop, you're done, okay? Because this hole happens at -1. So k is -1 in this case. All right, here's the last and final problem. So we've got another one. Again, it's a fractional problem. So you have three options. It's either a nice continuous function, it's an asymptote at x equals 4, or there's a hole at x equals 4. Those are the three things that could happen at x equals 4. So I'm going to do the same thing as last time. I'm going to graph it. Okay, whenever they're like this, I would highly advise just graphing it. Otherwise, you're going to get to the point where you're going to have a hole or an asymptote and you're not going to show what to do. All right, here we go. So I'm going to take my problem here and trace it. It's tracing. There you go. So something's happening at 4. It looks like it goes down. If I type in 4, it says nothing. So it's not the first one. So it's either this one or this one. Okay, so there's either an asymptote or there is the hole. So if it's either of these, if I type in an x value that's really, really close to the hole, or really, really close to the height of the asymptote, so just barely off, so instead of being 4, maybe like 4.001, it's going to give me an idea of what's happening. So I'm going to type in 4.00001, and I get 500,001. Ooh. So right here, the line's going along. You've got 4, and it goes up really, really high. Well, let's look at what happens from the other side. 3.9999999. Ooh, it's negatives. Okay. So in this case, we've got an asymptote going on. Is there anywhere along this line that we could put a single point to connect them? There's not. So when there's an asymptote, we cannot connect them. So in this case, there is no answer. It is impossible, kind of like with the parallel lines. It's impossible to make this continuous. So we are going to say that there's no answer. That's it.